So you're in charge of your little brother's party, and they have a face paint person come in, and 8 kids get blue face paint, 2 kids get white face paint, and then you think it'd be cute to have a picture with a kid with blue face paint and a kid with white face paint, and just 2 kids in the picture though. There's a lot of different kids to pick from. Please don't take your phone out during class. All right. My question is, how many different ways could you do it? Well, since the order doesn't matter, you should have picked a C, and you should have picked a C for each of them. Did you pick 8C1 and 2C1? Raise your hand if you did that right. Okay, awesome. Good, that's one important kind of question. I know you'd know how to type it in the calculator from there, right? Okay, all right, then the next thing. Let's talk about these charts. Heads, tails, copy this down. You just got a little tree diagram going here. Heads, tails. But then there's something else that you pick between. And let's keep it consistent with that blue-white thing. This will be blue or white. See, you flip a coin, and if you get heads, then you have to pick between blue or white face paint. And if you get tails, you also pick between blue or white face paint. And do you get, some kids are going to end up with heads and then blue face paint, and other kids will end up with the heads and then white face paint, and then some kids will end up with tails and blue face paint, etc. All right, now you have to be able to know enough about these charts to finish it if I just give you 2 numbers. This heads, tails, you know, it's normally 50-50. It's a weighted coin. It's 55% chance of heads. Next, from our results earlier, more kids seem to want the blue face paint. And we're going to say there is a 70% chance that the kid picks blue face paint. You now know all the other numbers, and you can tell me these 4 answers. This one right here would be the probability of heads and blue. This one would be the probability of heads then white. This one would be tails and blue. The last one would be tails and white. So your answers are like 0.3 and 0.65 or whatever. If you don't know how to do it, this is the moment where you need to ask for some help from the kid next to you. I think most people will know what to do here. All right, for the rest of the hour, I want you to be willing to just turn and ask that kid next to you if you don't know what's going on. I'm not going to make you slide next to each other, but please, don't be afraid to ask them, like, hey, what do you get for this one? What do you think? Okay? Act like they're your partner. Don't have to slide next to each other, but just talk about it. This. What's that? 25.5 times 0.70. Josie man, what if I was your partner, or sitting next to you, and I said, I just don't get how to do this part? What would you say? You just multiply those 2? Okay. Let me do that. What is 0.55 times 0.7?
0.55 times 0.7 is 0.385.
0.385. Is that what you guys thought it was? Raise your hand if you had that. You're right. Okay, good. How am I supposed to know what this number is? I had one kid who thought they added up to 0.55. No. What do these 2 add up to? 1. So this is 0.3. And they'd have to be the same. 0.7 and 0.3. And this one has to be 0.45 because they have to add up to 100%. You see how I filled out the whole chart? Now I just have to finish the multiplying. Do you feel like you could do that? I feel like that one's fairly easy. All right. Let's just finish it off and see what your four answers were. What is 0.55 times 0.3? 0.165. What is 0.45 times 0.7? 0.315. What is 0.45 times 0.3? And then, what if I asked you, what's the probability of getting heads and then white face paint? Heads and then white, 1.165. So that's 16% chance you were going to end up with a heads and face paint. Any questions? All right, then here's another one. Can you draw a tree like this for this situation? And listen, because if I say a dice, I'm rolling a die, you know, you might think that there's 6 branches. There isn't. There's only 3 if I do the problem this way. If I roll a die, where did I put this? There they are. There are 6 things that can happen, but I'm going to group them this way. I'm going to say this is 1 or 2. This is a 3 or a 4 could roll, or a 5 or a 6 could roll. Make the tree for that. There needs to be a probability on the branch. How are you supposed to know what the probability of that is? Well, do you know that on a die it's out of 6? It's something out of 6 then. Is it 1 out of 6?
No, it's 1/3.
It's going to be 2 out of 6. Raise your hand if you had 2 out of 6. Okay, good. And if that's 2 out of 6, this must be 2 out of 6. And this must be 2 out of 6. Does that make sense so far? Okay. Now, you flip a coin, and it's a normal coin, where it's a 0.5 chance of heads and 0.5 chance of tails. Finish the chart. I don't need you to multiply them all out at the end, but finish the chart. If there's a coin flip now, where it's a 0.5 chance of heads and a 0.5 chance of tails. All right. I think some of you could have done this and taken the test tomorrow and been okay. But again, really what I want for our review day is to have a lot of chance to do practice problems and ask questions. But today I'm going to be mostly just teaching you. I'll have a few minutes of work time, but okay. Now on the test, would we want you to actually multiply them out and get the answers? Yes. I'm not saying that you don't have to do that. You do, but I'm not going to do it this time because it just takes too much time. You know, you'd have to multiply 2/6 times 0.5 and put it here, 2/6 times 0.5 and put it there, and then, anyway, and they end up being the same answer a lot. So, that's how you do the tree kind of problems. All right, so many kinds of problems. Here's another kind. Expected value. Now, last time we did it where, let's say there was 3 envelopes. This one's $100, this one's 50, this one's 10. And I say, is it worth $1 to play the game? Well, of course it is. You're gonna get at least $10. And then I say, what's it really worth then? Is it worth like $50? And you might be like, no, then I'm mostly gonna lose or break even, so I don't like it. So what's the right amount? Well, you go the probability of this one times the amount you get. 1 in 3 chance you're going to get that $100 envelope times 100. And then the probability 1 in 3 times 50. And then the probability 1 in 3 times 10. And then you add them all up. Do you remember that kind? Okay. Now you have to be able to do that when it's not money. So the amount just might not be money. Let's see if you can figure out how this would work. It's still probability times amount and then add them. That's a really important like formula to use. You're going to take the probability times the amount and then add them. So in this story I tell you, you got to figure out the probabilities of each thing and the amounts for each thing, and you multiply them and you add them all up. So this is a real story. A family has 2 kids already, and they're thinking about having a 3rd kid. Okay? Let's say your best estimate is there's an 80% chance of 3 kids, as in they're going to go for their 3rd kid. They're going to have a 3rd kid. Then you tell me if they're not going to have 4 kids, they ruled that out. We're not having 4 kids, but we might have 3 kids. Then what's their probability of having 2 kids? This is not a super hard question. 20. So there's a 20% chance they're going to stay with 2 kids. And this is family 1. Family 2, they're more likely to stay with 2 kids. Let's say that there's a 70% chance you determine they're going to stay with 2 kids. They already have 2 kids, and they think they might just, that's good enough. But then there's a 30 of what? No, they already have 2 kids.
Having 3 kids?
3 kids. Now, is there a chance that they could go for 4? We're just ruling that out to keep it simple. If I wanted to, I could say there's a 10% chance they're going to have 4 kids. I just don't want to make the problem too complicated. So, do you get how there's probabilities and amounts? All right. Then, if these are the people who live in your neighborhood, there's the people over there with the 2 kids thinking about 3, people over there have 2 kids thinking about 3, but they're more likely to stick with 2, then how many kids are likely to be in your neighborhood? What's the expected value of this group of kids? Can you ask your question one more time? No, the order does not matter. Do you get the idea you're supposed to do the P times the A? Do it. Take a calculator. It'll just take you a second. Type in your probabilities. Type in your amounts. All right. 2.4 here. Point 4 there. .4 here. I think it's 0.9. Can anybody help with that one? It is? Okay, cool. I was just afraid of my decimal might be off because my back hurts right now and I'm trying to focus, but it's hard. All right. So this is 2.8, 3.8, 4.2, 5 point something. What'd you get? 5.1. Anybody else get 5.1? Yes? All right. So you do the P times the A, and then you add them up. So there's likely to be 5 kids in your neighborhood. And I know you could have just said that. Well, that one family's probably going to have another kid. So therefore it's 5. But this is a mathematical way to go exactly how many do we expect. All right. That's the P times the A, then add them all up kind. Next kind. I'm going to a lacrosse game. I'm going to just give you this problem. I'm going to do it for you, and then just to remind you how these look. I'm going to a lacrosse game where I'm going to be watching the goalie because he's my brother's son. No, my brother's grandson, actually. He's the goalie in this lacrosse game. And he wants to stop goals because he's a goalie. That's the point. So we're watching him play, and typically he can stop, let's say, 80% of the shots. Then, of course, that means 20% of the shots he does not stop. Okay? And if there's 3 shots at the end of the game, what's the probability he stops 2 of the 3? Well, here's the 3 shots. Here's the stops 2. This number gets copied here. Have you caught on yet that all of this goes together and is the thing that you're really concentrated on? Usually in sports, it's making shots. In this case, it's stopping shots because he's the goalie and he wants to stop, not to make shots. All right? And then this one has to be a 1 because these 2 numbers have to add up to this. Do you remember setting these up? All right. I think this will be a happy place on the test. I think this will be an easy one for you. But you also have to be able to type it all in. So I'm going to give you a new question, and then I'm going to ask you to set it up and type it in. On your blank notability doc, just set it up, please, first. Don't try to type it directly in. Too many things to have in your head. All right, so in this scenario, it's a hockey game. And the kid has a 75% chance of scoring on every time he takes a shot. Okay. He gets 5 shots in the game. What's the probability he makes 3? Just write out the formula for it. And then compare it with the kid next to you before you type it in. Just set it up and make sure you and the kid next to you set it up the same way. Just the written formula. The C in the 2 parentheses. All right, at this point, please compare with the kid next to you. See if we got the same formula, or ask them for help. Gabe, can you take out the other headphone? I think you forgot it in there. Compare your 7 formulas. Five shots make 3. 0.7 chance of make. And all this goes together. So then that means this 3 gets copied to here. And then there's a 0.25 that you miss, and there must be 2 of those. Raise your hand if you set it up right. Okay, good. Any questions? All right, we should move on to other harder kind of questions that you theoretically could do, but I don't think anybody in here is going to be able to do it. Like 0. So it's about permutations. Do you remember permutations? They have a P, right? All right. If I just asked it this simple, anybody could do it. There's 5 letters, and the order matters, and I want you to choose out groups of 5, and the order matters. Do you get that was 5? P, because the order matters, 5? Does that make sense to you so far? Order mattered, so it was a P. There was 5 letters, and I'm picking out all 5. What if I only picked out 4 letters? Well, then it'd be 5P4. You with me so far on that? And why do I care about the order? In words, does the order of the letters matter? Of course it does. It doesn't spell the word if you don't have them in the right order. Okay, so that's why the order matters, because it's a word. All right, but here's where it gets trickier. I don't know if you ever made this connection yet, but 5p5 is 5 factorial. When these numbers are the same, it's that simple. Now, 5 factorial, you might be like, I don't want to use this factorial thing. I'll just use the p on my calculator. You can't for this next kind of problem. You got to be able to use the factorial. So let's make sure you can find that. Everybody type in 5 and then go find the math button. This is on the graphing calculator. And then the PRB menu, math, probability. And then look for this thing. 5 factorial. What it means is 5 times 4 times 3 times 2 times 1. But trust me, you do not want to type it in that way. Because for the problems we're doing, you have to know where this exclamation marky thing is. Okay? I need to see that you know that. Type in 5 factorial on your calculator, hit enter, and I'm going to swing through. If that's 120, 5 factorial, then you have a chance of being able to answer this question. Okay? Purport is a word. It's got 1, 2, 3, 4, 5, 6, 7 letters. 7 factorial would be 7p7. I'm going to put out all the letters and I'm going to rearrange them in the order matters. Are you with me so far? But what's the trick on this one? There's some double letters. Do you think there's 2 p's? There's 2 r's and there's 2 o's? I doubt that you caught this, but on the day that we did permutations, there was some problems like this. There was a key where you theoretically could have figured it out, but here's what you should have done. It's not just 7p7, which would be this. It's also divide by, there's 2 p's, so 2 factorial, 2 o's, so 2 factorial, and there's 2 r's, another 2 factorial. And if you did all of that and forgot these parentheses right here, it wouldn't have worked. Because do you remember the deal with fractions? And if you don't put parentheses around the bottom of the fraction, it oftentimes does the wrong order. All right. Now, don't think these are like super hard. They are not super hard. You do need to learn this one. It should be a happy place, easy one. Now, I'm going to do a couple with you, and I think you're going to catch on. Now, I can do this one in my head. It's pretty easy because 7 factorial is 7, 6, 5, 4, 3, 2, 1. And then 2 factorial is 2 times 1, and another 2 times 1, and another 2 times 1. And so 2 times 1 times 2 times 1 times 2 times 1 is going to be 8. And then all of that multiplied together divided by 8 would be my answer. All right. Now, let's do another word. Tortoise. Any repeat letters? Yep. 7 letters, 7 factorial, over what? 2 factorial, because there's only 1 repeat and there was 2 of them. All right. Mississippi. It's not that scary. How many letters are there? We'll count it and I'll count it and we'll see if we get the same thing. What'd you get? 11, I agree. 11 factorial over. Now, is there any repeats?
Yep.
How many M's? Well, it's not. You don't do it like that. You find things that repeat. Is there something that repeats? Yeah, there's a lot of I's. How many I's are there?
4.
So you go 4 factorial. 4 factorial. 2 factorial. Got that? All right. I don't feel like these are that hard, but I guarantee you somebody's going to type this in from left to right. What did I say about parentheses? Got to put them in there on the bottom. Now, around a single thing, you don't need parentheses. And there's no point in putting parentheses around the top. If it's a single thing, like 11 factorial, your calculator is going to do that right. A single thing is not a thing. There's no reason for parentheses. But this is not a single thing. It's a whole bunch of things. You should have parentheses. If you want to be extra careful, just put parentheses around the top and the bottom. That won't hurt anything. If you can't remember, was it the top or the bottom? Put around both. All right. We're getting close to having covered all the tricky stuff that kind of got lost along the way while I was out sick. Or hurt, actually. Last thing I want to talk about is blanks. So imagine you have a password set on a safe. Let's say you and your sibling, whether it's your brother or sister, whatever, you've been stealing each other's junk, and then your parents say, I'm going to give you guys each a safe so you can lock it up so nobody steals your crap. And then you get the safe, and then you get to set the password. And it is 3 numbers and a letter. Remember these from the last test? See if you can answer the question just like that. There's 3 numbers. They're single-digit numbers. There's 3 of them. And there's a letter. And if I don't say anything, then that means anything can happen. Things can repeat. They could not repeat. Whatever. Just, there's no rules on it. If there's no rules, they can repeat. Do you remember this deal where it'd be 10 times 10 times 10 and then an extra 26 letters? So that's again like multiplying choices. Just like my shirts and pants example, I got probably 20 shirts at home, 5 pairs of pants at home. All I have to do is multiply them together, and I've got 20 times 5 is 100 combinations I could do. Okay? 20 times 5. You just multiply your choices. All right. Given that, what if the 3 numbers have to only be odd numbers because you really love odd numbers. You're going to only pick odd numbers. And about the letter, no 0 and no X. It's about choices. How many choices do you have? All right, please compare your setup. Don't even multiply them. Just compare your setup. What times what times what with the kid next to you. All right, so odd numbers only. Well, that's about half of them. So instead of 10, there's 5 and 5 and 5. And letters, well, there would have been 26, but you can't use 0. Wait a minute. 0 isn't a letter, so that didn't matter. But it does matter to the numbers. And if you can't use 0, then I'm going to count up my odds. 1 is an odd, 3, 5, 7, 9. Oh, there's still 5. Okay, so this one really didn't matter. All right, next, the no X. Well, there's 26 letters, and if you take out the X, then there's 25 letters. See how that worked? Okay, good. All right, so, yay. Now, I feel like I've covered everything, but you need a day to just actually practice. That's tomorrow. All right, so you have homework. Let me open it with you and find the problems that I want you to skip, and then there are some very specific problems you should do tonight. I know, it's homework. Nobody's ever excited about homework. But if you don't practice what I just showed you, that means you're going to have trouble on the hard ones, the R3s of the test. That I just went over basically a whole bunch of R3s. And if you practice them right now, you're on track for an A. If you don't practice tonight, very likely you're going to forget it, and forget it over the weekend. You'll have 4 days to forget everything I just taught you. And then test is on Monday. And that would be really bad. So just do your homework tonight. All right, here we go. Number 1 of the homework is a good one. You should do that. I need to see. Can you show me? It's that one, yeah. Now, one thing to warn you about, it says without a calculator. Cross off the without a calculator part. And skip number 2 entirely. So we're doing 1, but with calculator. You can pull it up as a something you can write on. And then problem 2 you're skipping. Problem, can you open that up bigger? Thank you. Thank you, that'll help. Problem 3, totally have to do something like that on the test. Problem 4, you're going to use blanks, so you should definitely do that one. Number 5, you definitely have something like that on the test too, so you got to do all of those. How about number 6? Yep, that's a P problem, I think, because I think the order matters. Number 7, it doesn't seem like the order matters on that one, so that's also important. Jeepers, a whole bunch of important ones in a row. Number 8, you can cross off. Number 9, you can cross off. Number 10, you should definitely do. Number 12 and 13 can be crossed off. So skip an 8, 10, 12, 13. Go up a little further. You should do 14 and you should do 15. You can skip 16. There now. That's a reason. Oh, wait, there's more. Wait, skip 18. And skip 19. Okay, now that's a very reasonable number of problems that are left. Do those. Check those against the key. And if you do that, you're really going to be on track for a good score. If you don't practice what I just taught you, it's just going to leave your head. And 4 days from now, you're going to be like, what was he even saying about that? It's a huge difference if you do this tonight or if you don't. All right, that's all I got for you for today.